Okay, I want to add a proforma to this uh, plan we've got here. It's a 5/2 resi building with retail on this street down here. We've got some parallel parking on the road. We have two levels of parking in the podium. Right now we're sufficiently parked, but we're going to spend some time building out our costs and assumptions. So our concept is done, but now we want to compare it against the financials and see what we need to do to tweak the yield here. So we're going to do all of that in Analytics. Let's open up Analytics and start with a blank slate. Now, bear in mind, whatever I show you here can be templatized and reused across many projects. But we're going to start from the very top. We're going to build everything up from scratch. So let's start with a top line category called built form. And this is going to act as my catch-all to help us just define some areas at the outset that we can report up the top here. So I'm going to add a new measure and we'll call this the number of dwellings. And it is unitless because we're just counting, and it's a property called dwelling count that lives on all the features that have dwelling count. So we just need component A. So we're literally just saying sum A across all of the different 17 features, and that'll give us 85. If I wanted to, I could isolate it down to a particular usage, but we'll just keep it at this collective usage here. So I have 85 dwellings. Let's add in our retail square footages. And I'm going to do that by just grabbing units again. We're going to say it's square feet. I care about the net area at this point, so I'm going to say net area in square feet. And we will isolate this one down to just retail. Again, it equals A. Let's add in the number of parking spaces. Again, this is a property called parking bay count, kind of like dwelling count. So whenever we're counting things, we try to keep it in as count. We'll say this number of parking bays. Again, it's unitless because we're just counting. And we want to sum that across all usages that have parking in them. So we'll say 152. Okay, so let's go and look at our costs now. I want to look at the costs for the road that we've built. I want to add a cost for each parking space. And I also want to add a cost for the structure, all the different structures, the park, and the trees. Let's actually add another built form calculation here called number of trees. Now this is an interesting one because Giraffe doesn't have a property that counts trees. So we have to figure it out ourselves. We'll call this tree count. It's unitless. It applies only to the tree. And we actually don't want to do anything here. We want it to equal 1. And we want it to count. And what that will do is just use the integer 1 and count it up for every tree that there is. So there's 20 trees. Okay. So let's add a new category. We'll call this capital expenses. And those capital expenses will relate to our construction costs for right now, plus any other one-off items, single items that we want to add in, line items. Before we do that, let's just go check all of our assumptions. So I'm going to open up the usage editor, and instead of looking at it usage by usage, I'm going to open up the table view. And this is a great way to edit lots of fields at once. So I'm going to zip over to hard costs. You can see hard costs are across the top here. They're organized alphabetically. So I come to H, and let's just zip down our different usage types. So our studios, we build those at 280 bucks a square foot. We don't have any of the standard residential usage type on this particular project. We're going to build our 1s and 2s at 350, and then our 3s are super luxe, so we'll make those 420. But let's also go ahead and add in a cost for our road. And now you'll notice that these don't tell you how they're calculated, and that's because we're going to define it later. So if we were to do a linear cost for road, it would obviously be very different than how we calculate for buildings, which is done on an area cost. So let's bear that in mind. For the road here, we'll build it out at, gosh, let's say $5,000 a foot. And our car parking, where is that? We're going to come down to, now car parking we could build out via a per area cost. Again, we can define how we want to calculate it. So we'll come down to our car park, wherever that might be, car park, there it is. Again, though, I'm going to do this at a different way completely. We're going to say it's $5,000 and we're going to calculate it per parking space. We want to add in our tree cost, so let's go find tree, there it is, and these are, I don't know, $800 a tree. And we want to add in road. We've done road, we've done tree, we've done parking. We want to do retail. There it is. And again, this is like a bit cheaper because it's really just a shell we're building, $220 a square foot. So let's save that and head back over to the model. Now you can see the next step is I need to define how all of those things are being calculated. So when it comes to our resi costs, like all this residential area here, I'm going to jump into our capital expenses and define a measure that is the hard costs multiplied by the area. And it's going to be gross area because we don't care for the net in this particular situation. So A multiplied by B. Now, we need to be careful here again because we're doing this with the generative toolset, so it has to apply across all of the usages, which means not just ones, twos, and threes, but also the corridors and the corridors and the hallways and the core spaces. So let's be very granular here and say I want to apply to 1 bedroom, 2 bedroom, 3 bedroom, core, and corridor. And I think we actually left those prices out when we previously calculated this, so we'll go back. We'll call this residential costs. The unit is in dollars, and that's ready for us to go. So 24 million for that that deal right there. But let's just jump back in, make sure we actually have a cost assigned for core. $1 a square foot, that's pretty good. So let's bring that up to $1.80 a square foot. And corridor. So again, let's do that, $1.80. All right. So that should give us a little higher cost, not much, but we need to make sure we're calculating all these things right. Now, if we were just using a simple massing, and I'll do this, I'll compare a scenario here at the end, we could just add in an efficiency to calculate what we need to there as opposed to just costs per square foot. But let's keep rolling here. So that's our residential costs. Then let's define how we want to calculate our tree cost. And again, that is the hard cost field, but this time it's multiplied by the count of trees, which we did in a previous measure. So we'll go into tree count, A times B, and it's just isolated down to the tree usage, and it's in dollary dues. So that should give us the nice healthy sum of 320,000. However, that looks awfully high. So we said 20 trees at trees. Let's have a look. At $800 a pop, so it should actually be 32,000, I think. Not even, it should be 16,000. 800 times 20 is 16,000, of course. So that's a good little lesson here on order of magnitude. And so what it's actually doing is it's multiplying the hard cost, which is on 20 trees, by the tree count 20 times, and then summing them together. So that's not what we want. That's obviously silly. So let's get rid of that, and we'll just define it manually. We'll say new calculation. It's a measure, or it relates to a previous measure, which is tree count, A multiplied by $800 per tree. And that is going to be our tree cost. in currency, 16,000. There we go. All right, great. Now let's add in our retail cost. And again, this is currency. It applies only to retail. It's based on that previous measure of the retail square footage multiplied by the retail count, the hard cost. Now you'll notice I'm nearly creating the same mistake here again. So what I need to do is, instead of using the reporting field, let's actually just go get the gross area. So at the moment, it's going to do that across everything that has a hard cost. We actually want to say isolate that down to just the retail usage. Equals A times B. Okay, resi cost, retail cost, tree costs. Now, what else do we need to look at? Parking bays. Okay, so we'll say parking costs. And again, this is something that we want to use the previous measure. So 152 parking spaces. A multiplied by $5,000 a parking bay. So we'll say parking costs. And it's in dollar dues. Save. And then lastly, we want to add in our road cost. And road cost is in the length of our road multiplied by our hard cost of our road. We'll go to road, A times B. Very nice. It's currency and it is costs, road cost. Now we can keep going here if we want to define things like the volume of soil moved and give a cut and fill kind of deal here. We can spend the time to model out the soil, because you can see it's really just relating geometries and to costs. So if we wanted to make those geometries volumetric, then we'd be able to do that as well. And note, all these parameters are live. So if I drag out this road here, for instance, you notice our road costs update, but also importantly, the areas are updating as well. So a very nice little ability to see what the impact of changing certain things will be. Okay, so that's really nice, but let's just spend some time formatting it. So I'm just going to add a display. We'll call this cost breakdown, and we'll add it in as a pie chart so we can sort of see who is taking the lion's share. And then we'll actually show the total sum of them as well. So we'll just save that. You can see now I've got this nice little pie chart showing us the cost breakdown and a total of 30 mil. By the way, if we have a fixed line item here, like for instance, a permitting cost, and that might just be a currency, it doesn't relate to anything in the model, it's just a constant, and it's 50,000. We may have a couple of these actually, so let's save that one, and then let's add in another one called finance fee. This could be, who knows, a percentage of the total hard costs, or it might just be a fixed number. Let's just put it in at 200,000. All right, so we've got our list of costs out here. We can see them happening dynamically. Now let's add a new category, and we'll call this category incomes. And our incomes, we're going to look at related to the model as well. But we could also then do operating expenses as opposed to capital expenses and calculate an NOI. So the goal here will be, we'll have capital expenses, we'll have our reporting metrics for the build form, we'll have our incomes, we'll have our net operating incomes, and then we'll do our return on costs versus our cap rate. So let's look at the incomes, okay? Obviously the park generates zero revenue. The retail will generate some rental revenue, but the bulk of our revenue is going to come from the dwellings here. And as we adjust the mixes, it's going to tell us a lot about, what the optimal use of this space is. So again, before we dive in here, I want to go and have a look at how we are, what rents we're tracking at the usage level. So I'm going to go to our one bedroom unit. And you can see on the 1-bedroom unit, we've got things like what's the price per dwelling, what's the number of cars that we're forecasting will come in here, and how many people. Now, this is more of a planning metric. So developers might not care about this as such, but from a planner's perspective, being able to forecast population here, amazing. So as we talk to the city of Atlanta, we may learn, okay, we actually need 1.2 cars per 1-bedroom unit, but we know that the amount we can get is very low here. So we want to actually crank this up to $2,100 per 1-bedder. And we'll save that. Let's drop down to the 2-bedder. And we know that this is actually much higher. So we'll say 2,300. And again, the city have mandated that we have 1.5 units, cars, spots per dwelling. 3, we said these were super luxe, so let's put them in at $3,200 a dwelling. 2 is about right. And then let's duck over to our studio, and again, that's very low. Let's put that up to 1,800 and save. Okay, so our incomes for the dwellings are per dwelling unit. So that'll affect how we do our calculation in analytics. And then let's pop over to our retail space and have a look at how rent is costed here. So you can see we've got net rent, $250 a square foot. This is way too high. Let's put it in more like, actually, I just deleted a number I didn't want to delete, so I'll discard those changes. Come back here, and we'll go retail. Net rent is going to be something more like $50 a square foot. And I'll save that. Okay, so now let's go and do those calculations. We've put our assumptions in, but let's go in and build them out. So I'll add a new measure. And again, we could do this for everything all at once, but we're going to define them separately. So we'll say residential yield, or we should say potential yield, because we're not going to factor in any vacancies or expenses at this point. So we'll go to price, dwelling total price, and we'll multiply that by the dwelling count. And so what this will actually do is it'll sum each of the, it will take the dwelling price, multiply it by the dwelling count for each object, and then it will sum it across all of the objects. So we'll say it's a currency, A times B gives us the total dwelling price. Our net income is 727,000 here. So let's save that. Now, 700,000 on a 30 mil project seems way too low. So let's pause for a second and just have a look and a think about what might be happening there. Dwelling total price. Let's just get rid of this and see what, well, let's first of all see what the dwelling total price is for 1-bedders. Okay. And if we said here, 315,000. So I'm just going to fact check this. Oh, I know what I've done. I haven't multiplied it by 12 to get it annual. There we go. All right, 8 million. That makes way more sense. Okay, so we have our yield of 8 million, potential yield of 8 million for the resi. Let's add in the retail. We'll use the same logic. And it'll be the net area of the retail multiplied by the net rent. A times B relates just to retail, and it's in dollars. Okay, 258,000. Nothing to sniff at. And nothing else here is going to make us any money, so that's going to be the sum of our incomes. Now, we could either simplify our NOI calculation, or we could go into building out a whole deal here and say, okay, let's take the OPEX Say we know that it's going to take X number of dollars. We have a person at the front desk, that's $70,000 a year. We have routine maintenance, which works out to be so much. Let's actually go through and do each of those. So we'll say staffing, and its currency. This is a fixed cost of $140,000 a year for 3 full-timers. And we'll add in another one called maintenance. This might be a percentage of all of the capital expenses. So we may go, you know what, we find that let's sum all the capital expenses, A, and multiply it by 5%. That is, generally speaking, what it costs us to maintain this building a year. Or maybe it's smaller, maybe it's like 1.5%. It's probably a bit healthier. And we'll save that. And then let's do another OPEX that is staffing, maintenance. What else might we be looking at? We have vacancy, that is going to cost us. We could look at all sorts of other things. But let's leave it at just those two for now. And then we'll do our, let's call this our results. So let's add in our NOI calculation. NOI, again, it's dollars, and it's based on the previous items that we've made. So it'll be, we'll take the sum of the two measures in incomes. We'll just take the subtotal of incomes, currency and incomes. Okay. We'll multiply it by a vacancy factor of 5%. Then we'll less B, where B is the currency and OPEX, so less our operating expenses. So we get down to 8.3 mil. So that's our NOI. Then we can add in another one, another result calculation that we'll say is going to be our return on cost. So we're going to do NOI on the sum of our capital expenses. So we'll call this return on costs. And it is a measure, well, it's based on previous measures, which is NOI, A over B, where B is the sum of all of our capital expenses, A over B. Now I need to times this by 100, and instead of it being a currency, it is a percent. And we can see our yield is 28%, which is bloody awesome. So that's pretty good. We'll pop that in there. And we could come down here and figure out what our cap rate is, etc., and start to look at our spread. But I'll leave this here right now. I'll stop here right now where we have a net operating income on top of our return on costs. And you can see how I've built this out from scratch and where our costs are starting to differ. So the only last thing I will do here is create a second scenario that looks to optimize our mix of units to see if we can actually get that return on cost slightly higher. So the first thing I'm going to do is create a new drawing layer down here. We'll call this rent optimized. And we're not going to do anything to change our concept because we like the concept. It's easy and cheap to build. We just want to tweak our yield here. And so to do that, I'm going to select everything on the original layer, and I'm going to hit copy. And you can see now my active layer is the rent optimized layer. So I'll come down, I'll turn off default layer. And now when I hit paste, it will paste onto the rent optimized layer. So I hit Control V. You can see new shape created on layer rent optimized. So now I have double of everything, which means all our costs, all our incomes, they've been doubled. Obviously our ratio of return on cost stays the same. But I need to go and then differentiate out in analytics between these two scenarios. So I'll do that by clicking on the configure button, settings, split by layer. And you can see there are my two scenarios side by side. Now, interestingly, this one has a slightly lower NOI. Why would that be? A residential potential yield? Oh, probably because the mix has already changed. So if we bring on, yeah, you can see the algorithm solved it differently both times. The second time I copied it. So that's perfect. That's what we want to experiment with. So this yield is obviously less efficient than the other yield. Let's click on it and actually just have a look at our mix of units. So I'm not going to change the sizes or anything like that. I'm purely going to focus on the mix based on those target rents we put in. So now you may learn here, okay, well, this is actually better that we do smaller units. So what happens, and keep your eye on the ROC over here, if we say, you know what, we don't want to do any three betters. We want it just to be predominantly studios, ones and twos. That was very interesting, right? Our studios are obviously not optimized, but there is a sweet spot. Around about here, I got it up to 33%. And then if we mess with this, can we get it any higher? I don't think so. So this is an awesome way when you put your comps into your rental yields to see, okay, where is the optimal mix here versus what will the market support? And tweak and tweak and tweak until you find it. So what we can see there is studios, ones and twos, and we may split this into two types of ones, like one with a den, or one floor plan A and one floor plan B to provide some sort of difference in the model. But just there, we found an additional 5% purely by adjusting the mix. And that may be the difference between your project penciling and not. So with that, I might leave it there. You can see the power of this pro forma. And the beautiful thing about Giraffe is you spend the time to do this once, and then we can say, okay, now I want this project to be the template project for every time I go in and do a multifamily scenario. So I'll say use as template, and I can define, is it for me, for my team, or for everyone? In this case, I want it to be available for everyone. So thanks for watching, guys. Hope that's useful for you.